Alright, so I went over this Monday. This is a unequal tangent vertical curve. And what that means is just simply a pair of two equal tangent curves. So once we get the curve set up, then we can solve them just like we did an equal tangent vertical curve. So it just simply means that the end of the vertical curve for one curve, and this one right here is a 400-foot curve, so it means there's 4 stations, and the second one is a 600-foot vertical curve. So the end vertical curve for the first curve is essentially the beginning vertical curve for the second one. And then they call the point a CVC. Now the CVC station is always directly above the V station. So this particular one, it was giving, the V was 87 plus 0, 0. So if you'll see, it doesn't look like it quite lines up in the book, but they're supposed to be right above it. So in other words, the V, your CVC station, will be above that or below that, depending on if it's a sag curve or a crest curve. So this one's a sag. So that's called a CVC. So it means there are two compound vertical curves that are equal tangent, but they're held together. So what we need to figure first is what the grade is at the beginning vertical curve, what the grade is at A, because this is the beginning of the second, the G2 for the first curve. So basically, this will be G1. And then we're going to figure the grade on the line A to B. That'll be our G2 for the first curve. And then when we do the 600-foot curve, the A to B will be the G1 for that curve, and the B to the N will be this plus 1.6%. Now, when we're looking at grades and you've got a negative, that means essentially the grades run from beginning vertical curve to the V. So in other words, we're going down on a negative 2%. If we want to figure the grade going back up, it's reversed. It would be a plus 2%. So we'll talk about that right there. But I can also tell you, if when we go to set this formula up, if you'll always put a negative for getting the elevation of the beginning vertical curve, the math will always add up for you. Alright, so L1 is 400, which is 4 stations, and L2 was 600. And it wants us to figure out A, and A is always going to be halfway between the what they call our V and beginning vertical curve. So in other words, that would be 2 stations because this is 400 feet. And then this curve, or this line from V to the end vertical curve, is 600. So this B would be at 8,700 plus 300, which is 90. So that's where the stations come from. So we actually need to figure out what the grades are to be able to calculate those. So I think everybody's pretty good with station numbers. So if the vertical curve, the V is at 87, and we're going to go back 4 stations, 400 feet, that would put me at 83 for the beginning vertical curve, and 85 for my point A, halfway. And then from the V to the end vertical curve, this is 87. So plus 6 would give me 93, and my B is halfway, which is L over 2, which would be 6 divided by 2, which would be 3 stations, so that would be 90. And then the CVC is always the station of the V. Alright, so we're going to put some numbers in here. So we want to calculate begin vertical curve, end vertical curve, CVC, and the line. So we're wanting to calculate elevations. Alright, so for the elevation of the beginning vertical curve, I'm going to do the elevation of V, and that is 743.24. If you'll always do, my handwriting's horrible. Let me see if I can straighten this out a little bit better. Elevation of beginning vertical curve is equal to, and it's going to be your elevation at your V which is the 743.24. So that comes from right here, the V. Now, then it's plus, well, they've got plus. If you will always put a negative right here, and keep your signs, it will always work out. So I normally put the grade here. So the grade is a -2%, and the curve is 400 feet, so that's 4 stations. So negative and negative makes a positive. So as you see, they actually put the length of the curve times the grade, and they just knew they were going up on a 2% if they were looking from V back to BVC. But typically always the curves, the grades come from the beginning vertical curve to the V, and then the V to the end vertical curve. But if you always put a minus there, the signs will work out. So for the elevation at begin vertical curve, that's going to give me 751.24 feet. Then if they're doing halfway, so elevation of A, it's 743.24 minus, and it's a -2%, and we're only going 2 stations, we're going halfway up. So that's always going to be L over 2. This is always L. And they got 747.24. So right now, we have just calculated the beginning vertical curve elevation. We've calculated the elevation of A, and now we're going to calculate the end elevation and then the elevation at B. So I'm going to put the elevation of V, 743.24. If you'll always do a plus when you're trying to calculate the end elevation, and always keep your signs, the math will work out. So this is a 1.6% grade times 6 stations. because it's 600 feet for this is our curve 2. So you should get 752.84. And then I want the elevation at B. And so that would be 743.24 plus your 1.6. And then this will be L over 2 in stations. So that would be 3. And you'll get 748.04. So now we have the elevation of B, and we have the elevation at the end vertical curve. Now what I need to know is what the grade is from A to B. So your grade, so I want to know what the grade is from AB line. Because remember, that's going to be our G2 for the first curve and our G1 for the second curve. So elevation A is 747. Oh, they do B first, sorry. The grade B is 748.04. Going to subtract the elevation at A, 747.24, and we're going to divide it by the length in stations, which is 5, because there's 500 feet. So if this one's at 85 and B's at 90, that's 500 feet or 5 stations. Basically, it's going to be half of your L over 2 for your first one, and half L over 2 for your second one. You remember the first one was 400 feet, so that would be 200, and the second one was 600, so that would be 300. So there's your 5 stations. So that means our grade is a 0.16%. Then now we need to get the grade or the elevation for our CVC station. And so that's the elevation where the two curves come together. So this time we're going to do our elevation from the elevation A, which is 747.24, and we're going to say plus our grade, which is 1.6, times 2. So the reason I did 2, so right here is point A, which is at 85, and we want to solve for the elevation of the beginning vertical curve, or CVC, which is end vertical curve for the first one, begin vertical curve for the second one. This CVC station is always going to be directly above your V. So I know that's got to be at station 87. So the distance between 85 and 87 would be 2 stations. So that elevation would be 747.56. Alright, so we've got everything we need now to be able to start with the curve information. So as for figuring out our R for the first curve, our R for our second curve, using equation 25.4, and then actually setting this up in a table form just like this. So I'm going to work a couple of them to show you how they're done. Alright, so remember 83 is the beginning vertical curve for 1. So 83, 84, 85, 86, and 87. So that's 1, 2, 3, 4 stations. So that's my first vertical curve. And remember the first vertical curve, the G1 is going to be the -2, and the G2 will be the positive plus 0.16. And then when we're doing the vertical curve for the second curve, this now is our G1, the 0.16. And our G2 will be the plus 1.6. So the formula for this equation is 25,4, and that's R equals, so they've got a R and a little 1 because that's our first curve. The formula is G2 minus G1 over L. So the G2 for the first one is at 0.16 minus our G1, which is a -2, all over L in stations. So remember, this is stations. And you would get 0.54%. So that's our R1. Our R2 is going to be G2 minus G1 over L in stations. Our G2 for the second curve is a 1.6, and it's going to be a minus a 0.16 because this is our G1 for the second curve over L in stations, which is 6 because it's 600 feet. And so R2 will be 0.24 stations. So that's the percentage. So they're both positive. Alright, so now we're ready to go ahead and solve and set these up in a table form. And remember, when we're setting this up, the beginning vertical curve goes right here. Your elevation for your CVC is going to go right here. And then you want to go, this one worked out perfect because they were on even stations, so 83 plus 0, 0. And to go to 84, this X is always in stations, so 83 to 84 will be 1. And the distance is always back to the beginning vertical curve. So from 85 to 83 would be 2. We're going another 1 station, 3, and 4. So the only thing we need to do now is do our, put the beginning vertical curve. And so for 84, so for me to calculate 84, it is 1 station. So our X is 1. And then we got the next column, which is G1 times X. And our G1 is flip from that page. Our G1 is a negative 2. So this would be a negative 2 times 1, because it's x, so that's where they just get a negative 2. So if you'll see right there, they've got negative 2. Our rx squared divided by 2. So our r for the first curve is 0.54. Our x would be 1 squared. Divide that by 2. And that's where they got 0.27. So I'm going to just kind of highlight the n number. I'm just working the formulas for you. And then the last one is your curve elevation. So remember the formula that we use, which is equation 25.5, which is y, which is the elevation of any point on the curve, equals the elevation at your beginning vertical curve plus g1 times x plus r so essentially the beginning vertical curve, so y equals 751.24 plus g1 times x, which was a negative 2, plus rx squared is 0.27, and you would get 749.51. So I'm going to write a little 84 underneath there. So you just keep all your signs. Don't make the mistake. I've had some make the mistake where they add the x in there. You don't add the x. You only add the second column, which is your g1 times x, because here's the formula. It's the beginning vertical curve elevation plus g1 times x plus rx squared divided by 2, which will be these two columns. So if you would set this up, you can either set it up in a chart form, or if you want to go back and figure each one out, kind of like what I did right there, you can. Alright, so this one I'm going to do for 85. So station 85, it's 2 stations from the beginning vertical curve, so my x would be 2. Then I have g1 times x, so that would be a 2 times the negative 2, because that's your percentage, so that's going to give me a negative 4. And then rx squared divided by 2. And our rx squared, our r is 0.54 times 2 squared, and divide that by 2. You should get 1.08. So I'm going to circle that and that. The reason we do the first column is so that we can figure out what x is, and then we just plug that into these two formulas here. Everything else will come straight from your problem. So now if I want to do the elevation, y equals 85. It's going to be your beginning vertical curve, so we're going back to that 751.24 plus a g1, our g1 times x, which is a negative 4, and plus our Rx squared, which is 1.08. And the elevation for 85 would be 748.32. So essentially what we're figuring out is what the elevation is on this curve. So we want to figure out what that elevation is right there at 84 and 85 that is on this curve. So we're following these curve grades here. And so this is how you would solve them. So of course they went on up and they did 86 and then 87. So if you keep all your numbers out, that 87, that 747.86, that should be what you calculated right here. So if you put everything in. Alright, so once you get to there, then we're going to pick up and we're going to start with our second curve. Remember, it's 600 feet. So we're going to go to the nearest 100-foot stations. So from 87 to 88 would be 1. So we have 1, 2, 3, 4, 5, 6. This now is going to be our beginning vertical curve for the second curve. Our G1 is going to be that 0.16. So it's going to be this grade now is our G1 for the next curve, and this would be our G2 for the next curve. So I'm going to write, this was all part of curve 1. Now we're going to start curve 2, and I'm going to use the same formulas and setting it up, and I'm going to go to station 88 first. So our first thing is X. Remember, this is in stations. So from the 87 to 88 is 1 station, and then G1 times X, so that would be a 1, let me write the grade, 0.16 times 1, that's going to give me a 0.16, and then R x squared divided by 2. The R for the second one is 0.24. Our x squared is 1, and divided by 2. I'm going to circle, and we would get 0.12. So as you can see, we're just solving so we can put it back into that curve formula. And so elevation of 88. And so the beginning vertical curve for 88 is going to be that CVC, which is 747.56. Plus G1 times X, so that'd be 0.16, plus Rx squared divided by 2, which is the 0.12. If you add those together, your elevation should be 747.84. So I'm going to go ahead and do elevation 89. Our X is 2, because there's 2 stations between 86 and 87. Our G1 times X would be 0.16 times 2. That would give you a 0.32, and I'm going to circle that one. And then R rx squared divided by 2. And our r is 0.24 times x squared divided by 2. And that'll be 0.48. So I'm going to circle that. And so the elevation of 89 will be the beginning vertical curve, 747.56 plus g1 times x plus rx squared divided by 2. And the elevation of 89 will be 748.36. And so keeping the chart form works out. So in other words, you'll keep this is your curve 1, this will be your curve 2. They're a little time consuming, but again, this has been seen on engineering exam, has been seen on surveying exams. So this is something I feel like you need to know, even though we know it does it for us in our CAD software. Alright, so you would finish out your chart and go from 1 all the way up to 6, and just using the same equations, watching what it asks for. Now this one worked out perfect because these were all 100-foot stations. So to do the first difference, second difference, they have to be 100-foot stations. So if this was an odd one at the end, like 93 plus 50, you could not do the first difference, second difference. You would have to start with the first one that's an even 100-foot station. So this one did. So the first difference is you take the 7, and you always start at the top. You would take the 752.84 and subtract the 751.36. You take the difference between the two, and they put it right up here. So they got 1.48. And then you'll take the next one down, 751.36 minus the 750.12, and they got 1.24. So you do that until you stop right where you can actually keep going with all of these, because it's gonna go from one curve to the other. So if you'll do the first difference, second difference, meaning taking the difference between the top number and the bottom number, starting at the top, do all of these in this column, and then work on your second difference. That would be starting at the top, and if you just keep your signs, so if this is a 1.43 minus the 1.24, you get a 0.24, and that's our R for our second curve. And then again, if you take the difference between these two, you're going to get 0.24. The next two would be 0.4. The next two, 0.4. The next two, 0.4. So they lined theirs up a little different. I kind of just did them off to the side, but this probably is a better way of keeping it. And then they started with the difference between these two, and there's where they got the negative 0.11. And then they did the difference between the 747.67 and the 748.82, and they put that right here. That'd be a negative 0.65. And like I said, if you will keep your signs, when you take a negative 0.111 minus a negative 0.65, you're going to get a positive 0.54, which is our R1. So once we checked all that, we can see that we didn't make a mistake anywhere here. And so lastly, if you wanted to check it, check your homework, and I actually put page numbers up here, so if you're using the new textbook, this would be on page 771. This time you would say for the one we're going to do, it would be an unequal tangent, and this one actually was an equal one. They're doing that. Well, no, they're doing both of them. They're separating it up. They're doing an equal tangent for one and an equal tangent for the other one, and getting the elevation. What they did is they put in station 85 as their V for the first one. But I think you can put in an unequal and it'll work out for you, so you can check your homework. If not, then we can do it as two separate ones, and then you can check your homework. So again, this is the wolf pack that I asked y'all if you want to copy down. That way you can kind of check your homework. Alright, so that's all for the unequal tangent curve. We did this in class Monday, but it's just a review to kind of help you when you're doing your homework.